Hi everyone. Today I'm very pleased to share my latest research, Edit2Perceive, which explores image edit models in perception tasks. The left is our model in the wild performance, and right is the ranking compared with totals. Let me first give problem definition and related works. The dense perception tasks, such as molecular estimation, surface normal estimation, and interactive matching, aim to understand 3D structure from 2D images, which is an ill-posed problem. The past successful experience includes depth anything, use tessellation, and plenty of training data, 1 million true and 16 million pseudo. And Marigold or Lotus use T2I version model to post-training. Other include Midas, GeoWizard, Stable Normal, Mate Anything, and so on. However, we discovered there is a gap between the T2I model and our perception task, because traditional T2I models focus on concepts to pixel semantic composition, which lacks an inherent capability of geometry, while our perception is a pixel-to-pixel or image-to-image task, which is more suitable for an image editing model like Flex.1 context. We do an easy experiment to show the difference. With same input and visualize the DS block, the self-attention map. In the same epoch, the I5 model is always better to get the geometry properties. And there is a problem that we do relative depth estimation, because the depth in real world is absolute metric, but relative metric is within the -1 to 1. So we have to pre-process it. There are different ways to do this transformation, such as direct minimax, but it severely compresses near-range details. Due to that, it's a long-tail distribution. See the left plot. Most pixels lies in 0 to 10, but there are some points in the 10 to 80, so minimax is not good. The Marigolds propose the percentile cut, use percentile 2 and percentile 98 to cut and then do the minimax. It preserves more detail, but still not good. And depth anything optimize is reciprocal, because reciprocal function grows fast in the near range and slow in the far range. Similarly, is logarithmic. It should also grow fast in the near and slow in the far. However, most of them, all of them are not good, not elegant. That's a problem. Our target is to find the best function fx, which minimizes the absolute relative error, which can be written as ABS real, generated by the entire pipeline of depth mapping and normalization and quantization in the interval x element to x max, which can be written in the follow formula. Here is a proof. Start from the fixed quantification error in bflow 16, we get delta d, and then from delta d to delta y and delta x, we finally get the relationship between delta x and the function fx, and use the formulation in the page, this page. We use integrity, and finally it can be written as 2 integrity multiply. So we use Cauchy inequation to derive f prime x is proportional to 1 by square root of x. Therefore, the fx is proportional to square root of x. This is another problem, that traditional formation is only implemented in the latent space, unlike supervision signals in pixel space. So we use 3 forms of pixel space consistently loss, depends on task, such as in depth is scale invariant L1, and in normal task it's the mean angular error, and in matching it's separating L1 error. And to use 2 losses simultaneously, we use an adaptive weight to balance 2 losses. Because we found that if we directly add the pixel level consistent loss into flow matching loss, it is likely to get model collapse and get the worst result. We guess that the origin model or the prior knowledge is mainly trained in the latent space, so it can't learn so quickly. So we let it focus on the flow match loss in latent space in the first epoch, and then gradually add the cycle consistency into it. Here is the ablation results, and that's the visualization. In the quantitative results, we get the best average ranking. See the right column. Our average rank is within 2, and the qualitative result is also good. We get refined details, especially such as the curtains in this, and this, and see this. Also, here our result is even better than GT. And here is the reference. I only list the classic ones. If you have any problem, please contact me in these ways. Thank you. That's all.